In science, when we use the word molecule, we mean there are two or more atoms that are reacting with one another. These atoms are bound together in order to achieve full valence shells. When we use the term compound, the atoms in the molecule consist of more than one type of atom. Hydrogen atoms are not stable, as they only have one valence electron. Hydrogen can react with itself, as we see here. Is it a molecule? Yes, there are two or more atoms interacting. Is it a compound? No, there is only one type of atom, hydrogen. Water consists of an oxygen atom and two hydrogen atoms. Is it a molecule? Yes, there are two or more atoms interacting. Is it a compound? Yes, there is more than one type of atom, oxygen and hydrogen. Now, the interactions we find between atoms in a molecule are called chemical bonds. And there are two main types of chemical bonds that atoms form with other atoms to achieve stability. Ionic bonds, in which atoms gain or lose electrons, and covalent bonds, in which atoms share electrons. Chemical bonds can be seen as a continuum. In some molecules, we see the atoms playing nice with each other and equally sharing their electrons, while in other interactions, atoms steal electrons from their partners. Let's first look at covalent bonds. Atoms that are covalently bonded may share electrons equally. Let's look at a molecule of hydrogen. As we discussed earlier, a lone hydrogen cannot exist on its own and can react with another hydrogen atom to fill that first valence shell. These two electrons are shared equally between both hydrogen atoms, filling the first shell for both. Are both atoms happy and stable? Yes. By sharing, this hydrogen has access to two valence electrons. That's a full first valence shell. And this atom also has access to those two electrons and has a filled valence shell. We can represent covalent bonds in many different ways. We can write the molecular formula H2. The H is the symbol for hydrogen, while the 2 indicates there are two atoms of hydrogen in this molecule. We can show how the electrons are distributed and shared, as in the electron distribution diagram. We can simplify this and show the Lewis dot structure, in which the valence electrons of the atoms are shared with dots, or the more popular structural formula, which only represents shared electrons with a line. As you can see, one line represents two shared electrons. And the space-filling model represents the molecule more realistically, with the union of electron orbitals. In the space-filling model, white is commonly used for the hydrogen atoms. Like hydrogen, oxygen atoms cannot exist on their own. How many electrons does each oxygen need to have a full valence shell? Yes, 2. And an oxygen atom can share 2 electrons with another oxygen atom to achieve stability. So, here are the ways we can represent oxygen molecules. If you notice, how many lines are between the two oxygen atoms in the structural formula? Yes, there are 2 lines. And how many electrons are shared in total when 2 oxygen atoms are covalently bonded? Yes, 4. Remember, each line represents 2 shared electrons. This is the best time to introduce the concept of electronegativity. Okay, big word, but don't be scared. Electronegativity is the attraction, or affinity, an atom has for electrons. Let's look at an example. Oxygen has a high degree of electronegativity. Why? Well, it needs 2 electrons to be stable, right? Not that many, just 2. And it has how many protons in its nucleus? 8, right. With all those positive protons, it has a strong affinity for electrons. But if we pair it with another atom that has the same degree of electronegativity, another atom of oxygen, what do you think will happen? Well, while one of them wants the electrons, the other oxygen atom wants the electrons just as much. So it's a stalemate. Neither oxygen atom can pull the electrons closer to itself because both atoms in the molecule have the same electronegativity, the same hunger for electrons. This results in a nonpolar covalent bond. Neither pole of this oxygen molecule has more electrons than the other. both atoms have equal possession of those 4 shared electrons. Okay, do you remember what the formula for water is? Right, H2O. How do you think the atoms are arranged in this molecule? Who shares electrons with who? Well, think about who needs what. So the hydrogens need 1 electron each? Should they bond with each other? No, that leaves oxygen out. So how many electrons does oxygen need? 2? How should they all hook up? Right. Does everyone have filled valence shells? Yes. And here's the different ways we can represent water. Now, do you think the atoms in water all share those electrons equally? Well, the hydrogens need 1 electron, but each has only 1 measly proton in their nucleus. That's a lot less than oxygen. So compared to oxygen, do you think the hydrogens are more or less electronegative? Oxygen has a much greater affinity for electrons than the hydrogens do. And when they form a molecule, the electrons are not equally shared, as oxygen attracts the electrons more strongly, and they spend more time in oxygen's valence shell than they do in the hydrogen's valence shells. This type of covalent bond is called a polar covalent bond. This results in the oxygen's pole of the molecule having a slight negative charge, as the negative electrons spend more time at that end. The hydrogen pole has a slightly positive charge, as the electrons spend less time at this end of the molecule. We will talk about this in more detail in the next lecture. Now it's time to move on to the next bond. Let's look at when atoms don't play nice with each other in the form of an ionic bond. Ionic bonds form between atoms with very different electronegativities. Let's take sodium and chlorine. How many valence electrons do they have? What do you think has a greater electronegativity? Right, since chlorine only needs 1 and has more protons in its nucleus than sodium, it is more electronegative. But are either happy alone? No. Both are unstable, as they do not have full valence shells. So if chlorine just needs 1 more electron to be stable and is highly electronegative, what do you think it will do? Yes, chlorine will steal sodium's 1 lonely valence electron. Are both atoms now stable? Yes, they now both have 8 electrons in their valence shells. They are happy and stable. But are the atoms still neutral? Remember, if the protons and electrons equal each other, the atom has a neutral charge. Well, are they? No, since sodium lost an electron, it now has 10 negative electrons and 11 positive protons. Overall, that gives it a positive charge. Chlorine gained an electron, so it now has 18 negative electrons and 17 positive protons, making it negatively charged. Charged atoms are called ions, and we can give them specific names depending on what kind of charge they have. Positive ions are called cations, and negative ions are called anions. The oppositely charged ions are attracted to each other, and this forms the ionic bond. When this occurs between sodium and chlorine, we get sodium chloride. When lots of chlorine and sodium atoms get together, crystals are formed. The salt you put on your food is a mass of sodium and chlorine atoms ionically bonded to one another, forming a structure called a crystal lattice.